Let's talk about binomial. We will be applying binomial theorem in these three examples that I've prepared for you. Now let me first write the binomial theorem equation. Now the last term is possible only when we have our exponent as integers, like in this example. X minus 3 squared or cubed. Let me just say squared. I'm sure we know the answer for a perfect square. A perfect square says x squared, the answer will be x squared minus 6x plus 9, because it will be the square of the first term, the product of these two times 2. Then you just find the square of the last term. That's how you get it. But now we will solve this using binomial theorem. So step number 1, you raise your first term by the exponent. So the exponent is 2. Next, you have plus. Drop that, you have 2x to 2 minus 1 times negative 3. Introduce this one now. Then you say plus. This is there. You'll have 2 into n is 2. N minus 1 is 2 minus 1. So 2 minus 1 is 1. Then we'll have times x to the power 2 minus 2 times, again we'll have that negative 3. This time which will be squared. Then we divide by 2 factorial. 1 factorial is 1, so you don't have to divide by that. 2 factorial is 2. Then say plus. Follow the same steps. So 2 times 1 times 0. So we'll have 2 into 1. And 2 minus 2 is 0 into 0. Then we have x squared minus 3, the exponent 2 minus 3 times negative 3. Now to the third exponent. Now if you notice, when you subtract here, this one is the positive exponent. So all of that should be divided by 3 factorial, and so on. No argument about that one. No argument about this one also, because we'll have, okay, let's start with the signs. Negative, this is to the power 1, so that means this is negative. Negative times positive will give us a negative. 2 times 3 will give us 6. X, 2 minus 1 will give us 1. So we have x to the power 1. Then move to the next one. Let's start with the signs. Squared. Negative 3 squared. Okay, negative squared is a positive. So that means positive and positive will give us a positive. We have 2 times 9. Because 3 squared is 9. So 2 times 9 is 18. We have 18. X to the power is 2 minus 2 is 0. Divided by 2 factorial, which is 2. Plus. This will be 0 because 2 times 1 times 0 will be 0. So this will be 0. Obviously the following ones will be 0. So that means this one stops right here because of the exponent. Then you have your x squared minus 6x plus 18 over 2 is 9. X to the power 0 is 1. So 9 times 1 is 9. Exactly what we expected, isn't it? So it's simple like that. Now let's do the second one. Let's move further to the next example. We'll have a square root of x minus y. Firstly, you need to change it into an exponential form. And then we can start to do what we're supposed to do. So first things first, we take the first term, bring the exponent onto it, plus bring the exponent to the front, so you have 1 over 2 times. Now you have that to the power 1 over 2 minus 1 times negative y divided by 1. So you can leave 1 divided by 1 factorial, but 1 factorial is still 1. Now why did I write this specifically like this? Because I want you to know that 2 is the denominator and that 1 goes with the numerator. So for all of them I'll write them like this. So we have plus, this does not change, it's still 1 over 2, still there because it's n. This is n minus 1. Now how can we get n minus 1? We'll say 2 times negative 1, it will give us negative 2. Then say 1 minus 2, it will give us negative 1. So we'll have times negative 1 over 2. So that's what we will have, negative 1 over 2. That's the exponent for that one. I can write it. So I know this exponent is minus 1 over 2. Then we move further to this one, to x. So we'll have x. Now you can see x is the numerator. X to the power half minus 2 times negative y. We have minus 2 here, we should have 2 here, divided by 2 plus, go on with it, start from the beginning. We have a half times minus a half. Now let's talk about this one. 2 times negative 2 is negative 4. 1 negative 4 is equal to minus 3. So here we have negative 3 over 2. So you come here and write that negative 3 over 2. Then we put our x raised by half minus 3 into negative y raised by 3, because this is negative 3, so this one is positive 3, divided by 3 factorial, and so on and so on. Then obviously for this one I cannot have y to the power n, because it will never reach y to the power. You can see there is no way where this exponent can become half. Makes sense, isn't it? Right. Then let's start to bring everything into a simpler thing. So we have our x raised by a half. Then let's come here, negative times a positive is a negative, so we have a negative sign. 1 times x to the power, okay, the moment you see a negative exponent, you know that x is underneath the line. And if the exponent is also a fraction, that means we have a set form. So in other words, we'll have 1 times negative y, which is negative y as a numerator. Now the denominator will be 2. Then you'll also put that x under a square root, or you can just put x to the power half, doesn't matter. Then you say plus. Okay, you are not sure, so you say 1 times 1, this negative times negative will become positive, so that means we'll have a positive sign here. 1 times 1 times y squared. The sign, okay, the sign of the exponent is negative, obviously x is underneath the line, so we'll have that there is y squared. So we'll have y squared over 2 times 2 times 2 factorial, that will be 8. 2 times 2 is 4. 2 factorial is equal to 2. So 2 times 4 is 8. Then we have our x to the power 3 over 2 underneath the line. Then we come to this one, negative times negative, that's a positive. This is cube, so that means it's negative times a negative times a negative, so that is negative. Negative times a positive, it will be a negative, so we have a negative here. Okay, let me change this. So we have 2 times 3, which is 6. 1 minus 6, it will be minus 5 over 2. So the exponent of x is negative, obviously x is underneath the line, so what is above the line is 3y cubed. So we have 3y cubed above the line. Underneath the line, remember this is 6. We said 3 factorial is 6. So we have 6 times 8. Because this is 2 times 2 times 2 times 6. So 2 times 2 is 4. 4 times 2 is 8. Times 6, that is 48. X to the power 5 over 2. Then if you want to leave it in set form, then you can just have your minus y over 2 root x plus 8 x to the power 3 y squared minus 48 x to the power 5 3y cubed. So this will be your answer. Right, our last example for this case will be x minus 1. Then the next one is plus, you multiply by that, so it's negative 1 into x minus 1 minus 1 times minus y. Okay, for this one, it's divided by 1 factorial, so you know 1 factorial is 1. Then you move to the next. You again take it to the front, so you'll have -1, -2, because -1 is -2. Then we have x raised by -1, -2 times -y squared. That will be divided by 2 factorial, plus do the same thing, -1, -2, -3, x -1, -3 into -y 2, 3, everything divided by 3 factorial. So this is what we have. This is 1 over x. Now this one, negative times negative is a positive, so it will be plus squared, but underneath the line, so this will be y over x squared. Then we come to the third term, negative times negative is a positive. Negative times negative is a positive, because we are squared is a positive, so we'll have a positive. Then we have our x being a negative, having a negative exponent, so that means it's below the line. So we have here 2 over 2, that will be 1. So in other words, we will end up having y squared over x cubed plus, okay, negative times negative is a negative. Then we are here, negative cube is also a negative. Negative times a negative, it will be a positive. 2 times 3, that's 6 over 6, so that is 1. So that means you'll have y cubed over x to the power 4, because that is -4. When it goes another line, it's +4. So this is how you will solve these problems. This is the third example. For now, I think I'm done. Now let's say we are given this question, we are given this diagram. Then obviously when you have it, the first thing you'll need to do is to do this labeling. You have this diagram, you're given that form, f of x is equal to square root x, or y is equal to square root x. So that means this is the curve, it's the parabola, but in this direction. So that is the parabola. Since yes, it's like that, so that means it ends at the origin. So you draw your line, you get your a and b, but you don't have to draw this thing, you don't have to draw. I'm drawing it so that it can make sense to you. Draw this line, you have your a and b, so we can get our gradient between a and b. Then the question says find m of f of x at a point 1 and 1. How can we do that? This is the formula we can use. Then how do we do it? We again follow our steps the normal way. We'll have the limit where h approaches 0. Now what is f of x plus h? We come here, this is our f of x. So in other words, we will use binomial theorem because we have a square root, isn't it? Yes, because we have a square root, we'll use binomial theorem, which is more like that one. Okay, let's do it. So that means you can just take f of x plus h alone. Okay, first things first, you'll have to change that your f of x, you can write here, therefore f of x is equal to x to the power half. So come here, you have changed it to be in an exponential form. Obviously now this will be negative half. This will be negative 3/2. And this is negative 5/2. But the sign is positive, obviously. So your x is underneath the line, so you'll have underneath the line, over the line will be h to x to the power half, then negative, I have a negative, x will be underneath the line, 2 times 2 times 2, that's 8, so you'll have 8x to the power 3/2, on top you'll have h squared. Same thing goes on, you'll have positive this time, so this will be the answer for us. So you take this answer, plug it there. If you want, for this one, since we know that we'll take h as a common factor just to make your work a little easier, then you can take out common factor h, and then you are left because all the remaining will always have an h, so we took out h as a common factor, so we can take this, substitute it there. Hey, I hope it will fit. Well, I was trying to make it fit there, so let's go with it here. Oh, it fitted, divided by h. This and that will finish, and this and that will cancel out after these are gone, and therefore we'll end up having the limit h tends to 0. Okay, this is not acceptable, né? You're not supposed to do this when you are writing your exam. First do this one, on the next step you can cancel these two, alright? But I just did them at the same time. Then we are left with that, which is 1/2 root x minus h over 8 root x cubed plus 3h squared over 48 root x to the power 5. Then now you can bring 0 everywhere, so you end up having, the moment you bring that 0, you no longer write the limit. Therefore, this will be 1 over 2 root x. This is your answer. But the question said that at a certain point where 1 and 1, where that point is 1 and 1, so you can say therefore this is the gradient of A and B. But now we want the gradient of 1 and 1. Let's jump this section and write underneath it. M at 1 and 1 is equal to 1 over 2 into 1, because now our x is 1, so you just put 1 in the place of x. Therefore, your answer will be a half. So this is how you will do this problem. Thank you.